Hello students, welcome back to your math classes. How are you all? I hope you all are healthy and doing well. So students, I'm your mathematics educator again here with a new chapter and a new concept. And today we are going to learn about the chapter number 11, which is geometry, right? So all of you, are you like geometry? Okay, fine, great. In the previous classes, we have read about point, line and segment. That is very easy chapter. That's why I'm asking you like this chapter, yes or no. So you already know about the line, point, line segment. This is your point. Okay. This is your point like this, a single point. If you want to create a line, this could be your line. Line segment means you have a starting and ending point. Next, a point is a mark signifying an exact location. It has no length, breadth or height because by seeing this, it has no length, no breadth and no height. The impression of a dot made by a fine pin or tip of a sharp pencil on a piece of paper are physical examples of a point. A point is denoted by a capital letter of English alphabet. You can represent this point as P, as Q. It's totally up to you. You can label it A to Z, any alphabet. 2 points shown alongside a name P and Q are read as point P and point Q. Now we have line. Line means by the word line we usually mean a straight line. It is a collection of points extending indefinitely in both directions along a straight path. You can get the idea of part of a line by holding a piece of thread by two ends such that it is a dot. The figure shows line AB written as this. So, this is your line AB. And how can you represent it? Writing AB and showing a line with arrows on both the sides. Now we have a line segment. A part of a line with two endpoints, it's called a line segment. The edge of a sheet of a paper, sides of a triangle, a taut piece of thread are examples of a line segment. So in line segment, we have a starting point and an ending point. So again, we can write AB, but in AB, now we have to represent it as a straight line only without any arrow because in line segment we cannot extend it further. Now we are going to learn about ray and angle. So first we have ray. A ray is a part of a straight line which extends indefinitely in one direction from one end point. Light emitted by the sun, a beam of light ray, a torch, and are physical examples of a ray. You can easily, if you want to see a physical example of ray, you can see the sunlight, you can make a torch in a dark room, then you are able to see your rays. And for making a rays, the figure shows ray OP denoted as this. How can we represent it our ray? A straight line on a single side arrow. In line segment, we have no arrow. In line, we have arrows on both the sides. And in ray, we have arrow on one side only. So O is the point of ray OP. Now an angle is a figure formed by two rays with the same initial point. So now we have two rays with the same initial point. So this section form your angle. The figure shows an angle formed by rays OP and OQ with the same initial point O. You can get the idea of an angle by observing some objects in your surroundings. So this is your angle. You have two rays and this is your angle. Two rays angle, two rays angles. So the common initial point, it's called the vertex of the angle, and the rays forming the angle called its arm or side. So these are your arm. This point O is your vertex, and this part it's called your angle. The figure shows an angle denoted as angle ABC or angle CBA or simple as angle B, its vertex B and its arms are BA and BC. Now the letter naming the vertex of angle is always written in the middle. Whenever you have to label a angle, what you have to do, this vertex angle should be always there. First we have to make a small angle sign like this, then CBA. Your vertex should be always in the middle of your rays. CBA, DEF, BABC, CBD. You can write them like this. Okay. Now, interior and exterior of an angle. So, these A and B are the points which lie inside your angle, and P are are the points which lie outside of the angle. An angle has two parts, interior and exterior. The point lying inside the angle form the interior of an angle. These are your interior points. Points A and B lie in the interior of an angle. The points lying outside the angle form the exterior angle of an angle. The points P, Q, R lie in the exterior of an angle. So points X, Y, Z lie on the angle. Now angles in different geometrical figures. So first in the figure alongside angle A, angle B, angle C are the angles of triangle ABC. The three letters of these angles are could be. So how can you represent? You have to take each and every angle middle. So A, B, C, A, C, B, B, A, C. What you have to keep in your mind? Each alphabet should be considered as your middle at one time, right? So in this we have take middle A, then middle B, and then middle C. You have to take your one alphabet between the two alphabet at least one time. In the figure alongside angle P, Q, R, S, same process we have to repeat here. QPS, PQR, QRS, angle PSR. So each angle should be lie between this, right? Now 11.1 we have our exercise. Which of the following figures show angle? Only C, because in this we have two rays and here we have our angle and a common initial point. So now in question number 2 we have to write the names of the angles in 3 letters and in 1 letter. So we have our angle only M, right? So angle M we have. Next, how can you write it? L, M, N by using 3 letters. In this we have angle Y, and how can we write in 3 letters? X, Y, Z. X, Y, Z. So you can easily write the letters in 3 letters and single letter for rest 2 parts you have. Write the names of all angles in each of the figures. So SQP, angle SQR, angle RQP, RQP. So students, you can write the name of the angles which are formed in the figure and part B, right? Write the 3 letter names of all angles in each section, 3 letter names. So first we have angle PQR, angle PRQ, angle RPQ. So by doing this, you can write the 3 letter name for rest of the parts you have. Now we are going to learn about the types of angles. So first we have right angle. Look at the picture of a clock. Observe the position of its hands. When it shows 3 o'clock or 9 o'clock, in this position, hands make a right angle. So whenever you see a symbol of L forming anywhere, you can easily write that angle could be your 90 degrees. So in this clock, what we notice, we are making an angle of 90 degree because we have our alphabet L, right? So whenever we have L alphabet, that means this is your 90 degree angle. Right angles in the environment we have in a television, in a book, and different in walls, in doors. So these are the right angles. Now we have acute, obtuse, and straight angles. Acute angles that are less than 90 degree are called acute angles. So if you see this figure, that is a little bit shifted to the this side. So this is your 90 degree, less than 90 degree angle. Okay. Next we have obtuse angle. So L shifted towards the right hand side. That's why this is your obtuse angle, which is more than 90 degree. You can simply understand it. If we have a L, this is your 90 degree. If we shift this line towards left hand side, right? So this could be your acute angle. If we shift this line towards right hand side, then it is your obtuse angle. So I hope so student, this is clear to you. Now, how can we measure an angle? So measuring an angle, we using this protractor, and we also say this protractor, the D. What you have to do, you have to put this point, this center on the initial point of the ray, right? Which you can also say the vertex of your angle. By doing that, you can easily measure your angles. Let's see how. It is called a protractor. It is used to measure an angle and to draw an angle of a given measure. A protractor is semicircular in the shape and its semicircular edge is divided into 180 equal parts. Each part represents 1 degree. 1 degree is written as this. 1 degree, this is the sign of degree. This 0 na, sign of degree. There are two sets of measurements marked on the semicircular edge, inner scale and outer scale. The inner scale has 0 to 180 degree from right to left anti-clockwise, and the outer scale has 0 to 180 degree from left to right clockwise. So the outer one will be your clockwise and the inner one would be your anti-clockwise. A line segment called the baseline runs parallel to the straight edge joining the 0 degree and 180 degree marks. The midpoint of this line segment, it's called the center of the protector. So now we have an example number 1 where we have to measure an angle with the help of our protector. So measure angle PQR using a protector. First what you have to do, you have to put this center on your vertex. So this is your vertex and then you have to see where this line overcross the numbers. So what we see, this number is overcross. You have to see always the inner semicircle. Okay. So this is your 70 degrees. So you can simply say that the angle PQR is equal to 70 degree. Now measure angle PQR using a protector. Again, the same process we have to repeat here. So what we have to see, this is your anti-clockwise, this 70 and 60 and we have 110 and 120. So what is the middle of 110 and 120? 115. So angle PQR is equal to 115 degree. What we observe here, for measuring an angle, we have to start counting from 0 degree mark of the protector, which coincide with the point other than the initial point on the ray along which the baseline of the protector has been placed. So in these 2 points, in example number 1 and example number 2, we are measuring our angles. In example number we simply just put the point at the vertex and see where this line overcross it and what is the measurement. So with which mark on the protector does the ray QP, the other arm of the angle coincide. Read the number so that mark this is the number measure of the given angle. Thus the measure angle of PQR 70 degrees. So by doing that you can easily measure it. And what things we have to keep in our mind? An angle of measure 90 degrees called right angle. An angle whose measure lies between 0 degree and 90 degree, it's called acute angle. An angle whose measure is between 90 degree and 180 degree, you can say more than 90 degree, that is your obtuse angle. So now we have our exercise 11.2 where we have to measure the angle. So measure the angles below and write the measure. So what you have to do, students, first you have to take your protector, put that center point on your vertex and see where AB stand, that is your measurement. So you just simply measure it and write your answer. Okay. So now we are going to learn about the construction of an angle. So in example number 3, draw angle ABC of measure 50 degree. So we are going to make an angle of 50 degree. Now what are the methods we have to use and what are the steps we have to follow? So the first step we have to do, draw a ray BC using a rule. So first of all we have to draw a ray BC. Why we are making a ray, not a line segment, not a line? Just because of that, because angle always form between two rays with a common vertex, right, with a common initial point. Now place the center point of protector on the point B and adjust it so that its baseline falls on the ray BC. Now read the markings on the inner scale of the protector. With the help of a pencil, put a dot, mark at 50 degree marking on the protector, name the point as A. Now remove the protector and draw a ray BA from the point B passing through the point A, and angle ABC is the required angle whose measure is 50 degree. So what we understand here, first of all we have to draw a ray. This is your point B where you have to put your protector point. After this you have to see this inner measurements. And according to this inner measurement where you see 50 degree, you just have to create another ray which is AB, and that's it. This is your 50 degree angle. This is method number 1. Now in example 4, draw angle XYZ of measure 140 degree. So what we do here, again we do make a ray YZ. After making a YZ, we have to take our protector, place it on the Y, which is our point. Now we have to see again the inner measurements and you have to see where is 140 degree. Just make another ray XY by putting a point like this. So in this you have to just make an angle with the help of your protractor by placing it your initial point, and where you see according to protractor where your 50 degree, where your 40 degree, put a point on that and just create another ray by following. Now in example exercise 11.3, we have draw angles of the given measure using a protractor, name the angle. So I already explained you how you have to make your angles, so follow these steps which we understood in these two examples, and after this you have to make angles for rest of the angles are given. Now we are going to learn about the types of lines. So the first type of lines we have parallel lines. What does mean by parallel lines? When two lines are at same distance from each other and never meet or cross, these are called parallel lines. Parallel lines, two lines we have like this, and if we extend it further, so they never get cross each other, they never get overlapped each other, these are your parallel lines. So this is the example of parallel lines. This is also, and this is also. It could be horizontal, it could be vertical, and it could be oblique. Just you have to consider two properties: they have equal distance, and the second, they never cross out each other after extension. Now intersecting line, the opposite of parallel lines, it's called your intersecting lines. When two lines that cross or meet each other are called intersecting lines. Two or more intersecting lines may have one point in common. So when you have two lines which are crossing each other, intersecting, crossing means we using a term in mathematics, intersecting, by when two lines are crossing each other. So these are your intersecting lines. Now we have perpendicular lines. Perpendicular lines, when two lines intersecting each other at the angle of 90 degree, that is called perpendicular lines. When two lines intersect each other in such a way that they make a right angle at the point of intersection are called perpendicular lines. Line AB and CD intersection at point O and make a right angle. The perpendicular lines are shown by the symbol of this. This is the symbol of your perpendicular lines. You can say opposite, reverse tree. Okay. Now we have coplanar lines. Two lines lie in the same plane are called coplanar lines. So these two lines are lie on in a same plane. That's why they are coplanar. In both the figures, line A, B, and C, D lie in the same plane. They are called coplanar lines. Now we are going to learn about the polygons we have. Okay. Now what does mean polygon? A polygon is a closed figure made up of three or more line segments. So the minimum requirement is three line segments we need to make a polygon. Our maximum could be any. So you can understand it. Now these line segments do not cross each other. Polygons are named according to the number of sides they have. A triangle is a polygon made up of three line segments. Why we called it triangle? Tri means three. So that's why we are calling it triangle, because it's made up of three line segments. A quadrilateral is a polygon made up of four line segments. A pentagon, penta means five, so it has five line segments. Hexagon 6, heptagon 7, octagon 8. Now we have triangle. Now we are going to learn about the polygons in deep. So first we have triangle. Triangle is a polygon made up of three sides. It has three vertices and three angles. It is represented by symbol triangle. This is the symbol. You just have to make a small triangle for representing a triangle. It's named as triangle ABC. Its sides are AB, BC, and AC, and vertex are A, B, and C, and angles also are angle A, angle B, angle C. Now what does mean by equilateral triangle? When we have a triangle with all three sides equal to each other, that is your equilateral triangle. With all sides equal in length and all angles are of equal measure, it's called equilateral triangle. For example, 3 centimeter, 3 centimeter, 3 centimeter, all three sides are equal to each other. Now we have isosceles triangle. A triangle with any two sides equal in length is called isosceles triangle. So when we have a triangle where we have only two equal sides, in this case we have AB is equal to AC, so this is your isosceles triangle. And the third one having any random measurement. Okay. Now we have scalene triangle. When all three sides of triangle are of different length, then it is called your scalene triangle. So 5 centimeter, 6 centimeter, 4 centimeter, all three have different measurement. Triangle with all three angles measure less than 90 degree. It's called acute angle triangle. If you have a triangle where you have all three angles less than 90 degree, then you refer it as your acute angle triangle. If you have a triangle where one angle is equal to 90 degree, then it is your right angle triangle. And if you have a triangle where we have only one angle more than 90 degree, that is your obtuse triangle. Always consider and always keep in your mind, students, that in obtuse triangle only one angle could be greater than 90 degree. Not all three should be greater than 90 degree. Okay. Now we have properties of triangle. So in properties of triangle, what we understand, the sum of all three angles of a triangle is 180 degree. The sum of all three angles, it's always equal to 180 degree. The sum of two sides of a triangle is greater than the third side. AB plus BC is always greater than AC. BC plus AC is always greater than AB, and CA plus AB is always greater than BC. So what we have to understand in property 2, whenever we add two sides of a triangle, we always have to consider that the sum of two sides should be greater than to the third side. It could not be equal, it could not be lesser, it should be greater than the third side. Now name the following triangles. This is 90 degree angle, we already learnt about this. Right angle triangle. Next, 2 centimeter, 2 centimeter, 2 centimeter means equilateral triangle. 2, 5, 4 means scale and triangle we have. Two angles of a triangle measure 60 degree and 70 degree. Find the measure of third angle. So we have two angle and we already know that the sum of all three angles is equal to 180 degree, right? So we have to add them together, 60 and 70, and the sum of it we have to subtract from 180 degree. So 180 minus 130 is equal to 50 degree. So the sum of third angle is equal to 50 degree. Now we are going to learn about the quadrilaterals. We have a polygon with four sides. It's called quadrilateral. A polygon with four sides. Each quadrilateral has four sides, four vertices and four angles. Sum of all the four angles of a quadrilateral is 360 degree. In triangle, we learned the sum of all three angles is equal to 180 degree, and in quadrilateral we have 360 degree. Square, first we have it's all the four sides are equal and opposite sides are parallel. It's each angle is 90 degree. So in square, all four sides are equal, all four angles are equal, and opposite sides are parallel to each other. Next we have rectangle. Opposite sides are equal to each other and parallel, and all angles are 90 degrees. So its opposite sides are equal and parallel. Its each angle is 90 degree. Parallelogram we have next. Its opposite sides are equal and parallel. Its opposite angles are also equal. Now next we have rhombus. Its opposite sides are parallel and all sides are equal and opposite angles are equal. Now we have our exercise 11.4. Write the lines given below as parallel, intersecting or perpendicular. This could be a perpendicular because in this we are seeing a 90 degree angle, not an intersection point. But in this we see an intersection point. So this is intersecting and this is parallel. For rest of the three, you have to classify among right, among intersecting, perpendicular or parallel. Name the following triangle. 60, 60, 60. It is equilateral triangle. 3, 3, 4. Isosceles triangle. 120 degree. This is obtuse triangle. Rest of the three you have to classify among obtuse, right, equilateral, isosceles and scalene triangle. Now write true or false for the following. Can a right triangle also be an isosceles triangle? It could be, no, it could not be an isosceles triangle. So this is false. If all angles of a triangle are acute, then it is called an acute angle triangle. Yes, this is true. For rest of the two, you have to answer is this true or false. Now match the following. So where we have a parallelogram, you can say that it is a parallelogram. This is a square. You have to keep in your mind the properties you learned about the quadrilaterals in your previous section. Then this part is very easy for you and you can easily solve it. Now we move forward and now we are going to learn about the circle. So we are familiar with objects such as automobile, wheels, bangles, etc. These objects are circular in shape. Take a 1 rupee coin, put it on a piece of paper, move the pencil around it to mark its boundary, take the coin away. The figure you get, it is a circle. We already know the poem which we learned in our earlier classes. Mummy ki roti gol gol, papa ka chashma gol gol, right? So the gol stands for circle we have, okay? Now drawing a circle, that is very easy. You just have to fasten your pencil into the compass, Make sure that your pencil is sharp and the metal tip of the compass and the pencil tip are in the same level. So what you have to do, this is the equipment, we called it a compass. There is a place we have where we put our pencil inside the compass. You have to settle down your compass and always make sure that your pencil nib and your compass nib should be equal to each other. After that, you just take a point, open your compass, any random measurement, or you can without any measurement, just open it, put your compass pin at a one particular point and then make a circle of it. Then you are see what you have made, your circle is prepared. Open the arms of the compass, then you have to open the compass, put the sharp point of the compass on the paper. Put the sharp point of the compasses on the paper at a point marked O. Then turn the compass around its metal tip with the pencil tip touching the paper. The figure traced by the pencil tip is a circle you have. Now center of a circle. The point you placed here, right? The point O, it's called the center of the circle. Every point on a circle is at the same distance from the center. Next we have radius of the circle. Align segments with one end point on the center and the other on the circle. It's called the radius of the circle. So this distance OY, OP and OX, these are your radius. Radius means we have to start a line from center and this line have to touch the edge of the circle at only one point, that is called your radius. The line segments OP, OY, OX are all radii, plural of radius of the circle. It should be noted that we can draw as many radii of circles as we want. Now diameter of the circle. So diameter means double of radius. It's called your diameter. A segment which passes through the center of the circle and its endpoints lie on the circle. It's called your diameter of the circle. In the above figure XY, this XY, in this case in radius, we have to start a line from center and then touches the edge of the circle. But in diameter case, a line overpass the center and then touches the another part of the circle, another edge of the circle. That's why it's called diameter, or that's why we are calling it double of radius. Okay. So now we have chord. Chord means when a line we are creating in a circle without passing through the center, that is your chord. So we can draw line segment AB whose endpoints A and B lie on the circle. The line segment AB may or may not contain the center O of the circle. Such line segments AB is called chord. Next, XY is your chord of the circle. We can draw any number of chords of a circle in figure. Second, we find that chord XY passes through the center O of the circle, is the longest chord that can be drawn in any circle. The longest chord XY is the diameter of the circle. So it could be touches the diameter, overcross the diameter. It could be overcross the center or it could not be. So that is your chord. The diameter of a circle is the longest chord of the circle. Now we are going to learn about the circumference of a circle. In this section, the boundary of the circle, it's called your circumference. The circumference of a circle is the distance around the circle. In other words, the perimeter of circle is called its circumference. Okay, students. Next, we can measure the approximate circumference of circles with a measuring tape, thread or a strip of paper marked in centimeters. The approximate length of the circle can be found with the help of a thread. Take a long thread pipe. You have to take any circular thing, any circular object, and with the help of a thread, you can easily measure it. You have to round on it, put it, and then you take that thread and measure on your ruler how many centimeters the thread measure. That is your circumference. That easy is this. Now we have our exercise 11.5. You have to fill in the blanks. Diameter is the longest chord of a circle. Diameter of a circle is double its radius. A line segment joining any 2 points on the circle is known as the dash of the circle. So you have to tell me what we called it, and rest 3 parts you have to answer your own. Now draw circles having the following radii. So you have 3 centimeter. You just have what you have to do. Put your pencil in the compass. Then you have to open the arms of the compass from 0 to 3 centimeter by measuring it over your ruler. After this, you just have to put a pin of your compass and then make a round. So you were see your circle is prepared for radius 3 centimeters. Same you have to do for 4 centimeter and 5 centimeter. Draw circles having the following diameter. So in this case you have this diameter. So for preparing for making a circle we need a radii. So for making a circle we need a radius. So we have to take first radius 8 centimeters. So half of it is our radius. So 4 centimeter is our radius. Now we have to open our compass for 4 centimeter. After that we just put a pin over a paper and then make a circle. Identify the following in the given circle. So this first we have to find a chord. So MN is your chord and AB is also your chord. Radius OP and diameter you have to write. Now draw line segments AB of 6 centimeter with the help of a compasses by taking A and B as centers. Draw two circles having radii 2 centimeter and 1.5 centimeter respectively. Do these two circles touch each other or not? So you have to do this. What you have to do? First you have to make two circles 2 centimeter and 1.5 centimeter, and while you making this circle you identify it these both circles are not touches each other, and after that you have to draw a line segment of 6 centimeter. That is very easy for you. Now take a line segment AB of length 8 centimeter with A and B as center. Draw two circles having 5 centimeter and 3 centimeter radii. Confirm whether these two circles touches each other or not. So you have to make a line segment 8 centimeter. After this your A point, this is your B point. Now you have to measure 5 centimeter on your compass. Place it on this. You have to place your compass pin here and then you have to make a circle like this. Same process with the radius of 3 centimeter. Put a compass pin here and then you have to make a 3 centimeter. So this kind of figure you have to make. Okay students, now we move forward and you have your mathematics lab activity which you have to perform in your maths lab. So this is the end of your chapter. I hope so. You understood it very well. If you have any kind of doubt in a particular concept, you have to first revise it and then do some kind of questions related to that particular concept. After that you feel you were clarify your all doubt. So students, now going to meet you in your next class. Till that, bye bye. Have a good day.